this is chapter 3, section 3, and this is all about, now that we know what an atom is, we can talk about how we can count them and what the different parts on the periodic table mean. So we're going to be able to talk about atomic numbers, atomic masses, relative atomic masses, average masses. We're going to talk a little bit about Avogadro's number and how we group and count atoms, and we'll add those conversions in. So let's just jump right into it. So the atomic number and isotopes are really important concepts. The atomic number of an atom or an element is represented by the letter Z, and it's the number of protons that each atom of that element has. Now, isotopes are atoms with the same number of protons, with the same atomic number, but they do have different numbers of neutrons. So they're the same element, they're just a little different with the different numbers of neutrons, but they don't really have any different chemical behavior or reactivity. So for example, here we have the protons, and the neutrons, and then these are all different isotopes of hydrogen. Okay? So moving on, here is our example of a block on the periodic table. And before we jump into that, let's talk about mass number. Mass number is the total number of protons and neutrons that make up the nucleus of a particular isotope. So any particular atom has a mass number, whether it's just the protons plus the neutrons. And on a standard atom, that would be usually double whatever this number is, but sometimes it's different depending on what it has in it. So you just have to check the periodic table. So here's the atomic number. Again, that's the number of protons. We have our element symbol, we have the name, and then we have the atomic mass. Now the atomic mass on the periodic table is that weighted average, and we're going to talk about that in just a minute. But you can usually look at this number and determine how many protons and neutrons there are. You would subtract the atomic number or the number of protons from this number to get the number of neutrons. And neutrons are always in a whole number. The decimals come from that weighted average that we're going to talk about in just a second. All right. So again, here we're going to talk about isotopes. And isotopes can be written in two ways. We have the hyphen notation, which is just the name of the element, and then the mass number, And then you can also have the nuclear symbol, which has the mass number and then the proton number written beside the element symbol. So mass number and atomic number, whereas this one is just the name and the mass number. And we could do some sample problems with those. This one's a really good one. How many protons, electrons, and neutrons make up the atom of bromine 80? So 80 is our mass number. We look at the periodic table to tell that that bromine is right here. It has a mass number of 80, okay? And the atomic number is 35. So we subtract the 35 from 80 to get 35 protons, 35 electrons, and 45 neutrons. To get the neutrons, again, you subtract that proton number or the atomic number from the 80 to get 45. Now, given the periodic table, it has 35 protons, and unless it's written as a charge, you always assume that the protons and the electrons are the same. All right, so this is the relative and average atomic masses. This is what I was talking about with the decimal points. So the average numbers at the bottom that show the mass number. So we have the atomic number, our symbol, our name, and then our mass number. Those decimals indicate our average mass. And it works just like a grade average, or a weighted average for a grade. And we'll show how to do the math in just a second. But for every atomic mass unit, it's basically one proton or one neutron. They both weigh one atomic mass units. That's our unit. And the average atomic mass is the weighted average of all the isotopes that exist in the planet. And we'll talk about how to calculate those in the next video.